Hello everyone, welcome back to my tutorial. In this tutorial, we will solve a thermal analysis using Salome meca. So our problem is a plate of length 0.5 mm and height is 1 meter, 0.5 meter and 1 meter. Thermal conductivity of the plate is 60.5 watt per meter Kelvin. We'll do the linear static thermal analysis, and in this case we'll be solving in a 2D case. We'll be modeling in a 2D and we'll be analyzing it. So only 2D we will draw and we'll create a mesh, then finally we'll get the results. Okay, so first just open Salome meca. Go to geometry. So our geometry is 0.5 meter length and 1 meter height. So go. Now we can directly create a rectangle by using 2D sketch. Rectangle, first point is 0 0 and next this corner point is 0.5, y is 1. Apply and close. Now we can check, this is the rectangle. Now this is a line actually. So for that we need to build a face similar to ANSYS. So go to build face, apply and close. Now we have built the face. Then we need to create groups for applying the boundary condition. For that, right click here and create group. This is a volume group. Just select all, apply. Then to apply boundary conditions, now check the case. Top edge having a temperature of 170 degrees Celsius and bottom edge having a temperature of 100 degrees Celsius. Remaining you keep it as it is. So just go top edge, add, this is top edge, apply, and select this bottom edge, add bottom edge, apply and close. Now you can see top edge, bottom edge. This both you can name it similar. So top edge and bottom edge. So then we have created our geometry and we have created groups for to apply boundary conditions. Then we can save this file. So I have saved it. Then we can go for meshing. Select this face one, mesh, create mesh. Now go for quadrilateral mapping, go to 1D, wire discretization. Here you can go for different algorithms. Now I'm going to use local length, specify 0.05, then OK, apply and close, then right click, compute. So this is a mesh we have generated. This is the size of the element we have specified that. Now you can check it here. So top edge, bottom edge, and this is a face. Now we have created the mesh. Then we can go for solving in Aster. Now go to Aster, choose table, then click OK. Now we can use assistant to generate the command file. Now right click here, go for add a stage with assistant. The first one you can see linear thermal analysis. So choose this one, linear thermal analysis. Here you can see it. This wizard will create simple linear thermal analysis. Boundary condition we can impose constant temperature, normal streams and volume stores. So normal stream is nothing but flux we can give, and volumetric heat source we can give, and constant temperature only we can give. Okay, so we can use 2D and 3D meshes. So go to next, So mesh it has taken from the mesh module. Go to mesh. Here we need to choose plane. Next, so thermal conductivity. So thermal conductivity of our model is 60.5. So specify 60.5. Then go to next. Now we can give imposed temperature. So bottom edge, okay. So bottom edge temperature is 100 degrees Celsius. So that means just to specify 100. Then one more imposed temperature is top edge, okay. This one is 170. Then go to next. So do you want to add streams and normal to the face? No. And do you want to add volumetric sources? No. Go to next. Now we can save the result file. Go to browser, pictures, code Aster 10. Here we can name it as result 12.rmad. So already I have results here, that's why I am naming as 12. Save it and finish it. Now you can see we have, this is the command file it has generated by using the assistant. So this is input file, this is output file. Now what it will do, it will only generate temperature as the primary variable. If you want to see flux also, so we just want to calculate from the temperature. So this is the mesh. We can read the mesh, then defining the model. This is a thermic, and defining the material and assigning the material. For linear thermal analysis, thermal conductivity is enough to solve the problem. Then boundary conditions, we have applied two boundary conditions. So that fixed temperature, one is 100, another one is 170. So analysis, we are doing linear thermal analysis. Thermal linear is a command for that. Then we just want to calculate flux also. For that, go for post processing, call champ. Here the name you just give as a temp. So temp is the name. Here we can specify it have thermic, add it. First one we can give flux L no, and next one we can give flux node. Then we can give tau to OUI, then OK. Now we have calculated. Then the same thing we need to get from the output. So here we need to get it from the output. So first one is temperature, next one we can take it as here we can specify it as temperature is already there. Next one is we can specify it F flux node. Okay, then OK. Then I can give OK. Now you can see first one, both thing we need to specify. Now right click here. Here also we can edit it. Here it has to take temperature. Then OK. First one is temperature, next one is flux. This two thing it will write in the output file to view the results in Paraview. So now we have done. Now save this file. Now go to history, a current case. First run, then again save keep the files, then you just refresh in 5 seconds and run it. Now cases are running. Now the case is finished with without any error. Now you can check this message file. Here you can see diagnostic job is OK. That means there is no error came in this So just close this file. Now we can open this output result file in Paraview. Go to Paraview, just open. Now go to pictures, code Aster, 2D case. Our result file I have named it result12.rmd. Just select this file and click OK. Now you can see temperature and flux, both the results are came. Just apply it. Now we'll see the temperature first. So temperature is the scalar value, that's why there is no data is came here. Now you just go here, then change this into rainbow blue to red, apply and close. Again go here, specify into 12. So this is the temperature distribution. Now we can go for flux. So flux is the, here we have only two coordinate, x and y. So flux x and flux y. This is the flux x and this is the flux y, and this is the flux magnitude. In this we have done the linear thermal analysis. To view the case file, you just go to the location where we have run the case. So here we can see the case files. So all the files will be stored here. So this is a message file, this is the command file. So in this we have completed this linear thermal analysis of 2D case. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.